Hello everyone, my name is Jessica Vilela. I'm a professor of software engineering, safety and information security at UFPE in Recife, Brazil. Today I'm gonna talk about our journal first paper published at Transactional Software Engineering Journal. It is a result of my PhD and it is called Safety Practices in Requirement Engineering, the Uni-REPM Safety Model. Here is our agenda. First, we'll talk about our motivation and goal. Then, the steps of the research methodology we follow to conduct this work. Then, we explain our proposal, the Uni-REPM for Safety Critical Systems. Next, we will talk about the initial steps of the validation of our proposal. And we provide our conclusion and present further research. In this work, we address the development of safety-critical systems. These systems can be defined as a set of hardware, software, process, data, and people whose failure could result in accidents that cause damage to the environment, financial losses, injury to people, and loss of lives. They are used in many domains such as transportation, cars, airplanes, trains, in medical devices, among other domains. All these systems have users that interact with the system and also interact with the environment and people. Our scenario is: first, the literature reports that problems with the requirement engineering process of safety critical systems contribute to death and injuries in many safety incidents and safety-related catastrophes. Second, software has become a major software risks and hazards since it can give wrong instructions to the system hardware through actuators that can lead to accidents and hurt people. Third, another point is that companies face some issues such as absence of systematization of available safety actions, a lack of a model to guide them on how to apply their efforts systematically, and difficulty in determining and assigning priorities to safety actions to be adopted. Accordingly, we argue that the safety early consideration of safety concerns in requirement engineering should be a top priority in the development of safety critical systems, since requirement engineering is essential for software quality and effectiveness of software development process. Moreover, high safety levels are typically best achieved by addressing safety from the beginning, not by trying to add protection components and additional complexities after the system has been developed. Hence, our rationale to develop this work is that mature companies do their business in a systematic and proactive approach. On the other hand, immature companies can and do produce good quality requirements documents, but they may not be able to do so consistently or when working with tight deadlines. Such companies lay emphasis on fixing problems right away and on obtaining their results through the efforts of determined subject, while deadlines and budgets are often exceeded. Hence, a mature and practical process contributes to eliminate errors and requirements problems from the beginning. There are some requirement engineering assessment frameworks that allow companies to evaluate their strengths and weaknesses regarding their requirement engineering process. However, this maturity model do not cover both market-driven and bespoke requirement engineering at the same time. To fill this gap, Uni-REPM was proposed, but it did not originally consider the safety practice required to the development of a safety critical system. A maturity model that explicitly addressed safety in requirement engineering process could not be identified. Instead, there are safety maturity models such as a safety extension for CMMI called Safe CMMI Dev and that is the ISO 15504 Part 10. The Uni-REPM safety model differs from these safety maturity models in terms of purpose, scope, intended usage, and number of practices. Considering this context, this paper proposes a safety maturity model for Uni-REPM, which is the Unified Requirement Engineer Process Maturity Model, which covers both market-driven and bespoke requirement engineering at the same time. Our model, called Uni-REPM SCS for Safety Critical Systems, can be used by companies as a guide to access and improve their current safety practices and process. Hence, our goal is improve the quality of safety requirement engineering process by developing a safety model for Uni-REPM maturity model, which is useful and suitable to domain independent systems in order to increase the safety process maturity levels and further develop safer systems. We follow the design science methodology as a research method to develop the safety model. The steps of the methodology we adopt to construct the Uni-REPM SCS are presented in figure on the left. The model construction process involved 9 steps. Although methodologies for creating maturity model are available in the literature and inspire our model, we add new steps as needed based on our experience and opinion along the way. We have done several works on safety critical systems and with companies involved in safety critical development to collect data and to define the practices to be included in a requirement engineering model for safety critical systems, including we perform 2 systematic literature reviews, we conduct empirical studies with 11 companies and elaborate technical reports, we examine safety standards, we analyze existing maturity models, and we conduct a comprehensive analysis of important authors in the field. Our solution is a safety model for the Uni-REPM maturity model. The model follows the same hierarchy of Uni-REPM that defines 3 levels presented in this figure. The first level is the main process area, MPA, which were proposed by Uni-REPM that were defined considering well-adopted requirement engineering process. It has 7 processes: organization support, requirement process management, requirements elicitation, requirements analysis, release planning, documentation and requirement specification, and requirements validation. The second level is the sub-process area, SPA. In this figure, we present the safety model and its relationship with Uni-REPM. The model extends Uni-REPM by adding 14 new SPAs highlighted in orange and with dashed lines in this figure, and they are connected to the 7 MPAs. The SPAs are Safety Knowledge Management, Safety Tool Support, General Safety Management, Safety Planning, Safety Configuration Management, Safety Communication, Safety Traceability, Supplier Management, Preliminary Safety Analysis, Failure Handling, Safety Certification, Human Factors, Safety Documentation, and finally Safety Validation and Verification. It is important to note that Uni-REPM existing process and sub-process were not changed and none were removed in our work. At the low level of the model structure, we have actions that represent a specific good safety practice. For example, an action called Develop a Safety Information System to share knowledge in the organization, once implemented, will enable partners to share knowledge in the organization, improve the communication among them. In the safety model, actions also follow the same format assigned to sub-process to define their unique identifiers and also used to define safety extensions. Actions are identified by the MPA and the SPA under which they reside, followed by NA, which stands for action in their position in the group. For example, os.skm.a1 means the first action under MPA organizational support and SPA safety knowledge management. Beside the description of each action, there can be recommendation and support actions. Recommendation provides suggestions on well-adopted techniques or supporting tools to practitioners implementing an action. On the other hand, supporting actions define links to other actions which will benefit the practitioners if they are implemented together. The maturity level view was developed by assigning a level to each safety action in a scale from 1 to 3, corresponding to basic, the first level, which is a rudimentary repeatable safety requirement engineering process. Level 2, intermediate, that is more rigorous. And level 3, advanced, that represents the most mature process. The safety model was designed to be used through an online assessment instrument. We developed a tool that supports both requirement and safety evaluations, and it supports three types of users: external and internal evaluators and administrators. The instrument has a query to evaluate each safety action in which the evaluator can select one of three options. Complete, the action was done in the requirement engineering process. Incomplete, the action was deemed vital but was done partially or done at all in the requirement engineering process. Not applicable, the action does not apply to the evaluated process. After answering all questions presented in the assessment instrument, the tool determines and presents the evaluation results. An example of evaluation of SPA safety planning is described in the table on the left. The assessment results can also be presented graphically, as for example on this figure on the right. We also performed an initial validation of Uni-REPM SCS. We followed the technology transfer framework and we conducted a stack validation, which proposed collecting expert opinions in order to find out whether the knowledge in literature was reasonably transferred and presented in our model. We evaluate our proposal considering three aspects: coverage, correctness, as well as user-friendliness and applicability. We interviewed 2 industry practitioners and we conducted a survey with 9 domain experts. The subjects have an average of 11 years of experience. They acted in several domains. They performed several roles and they know different safety standards. We received suggestions both to increase and decrease the maturity level of the actions we proposed. We also identified conflicts of suggestions to the same action, and we implement the great majority of suggestions. Finally, the practice states that our safety model has the potential to help requirement engineers to perform safety-related activities or tasks in a project. We envision some benefits in adopting our safety model. We see benefits to academia since it offers a comprehensive summary of a state of the art by providing the identification and systematization of existing safety practices being a knowledge base. The model has initially validate with 11 practitioners that provide a valuable contribution to improve our proposal. And there are also benefits to industry. First, we have an online to support the availability of assessment instrument in our website. It offers to companies that develop safety critical system a way to evaluate and provide the requirement engineering process. It allows a company to evaluate specific concerns such as a specific MPA or SPA. It also enables companies that did not originally develop safety critical systems to incorporate safety aspects into their requirement engineering process. This work has generated some research directions that should be explored in future efforts. We envision 6 points to be investigated. The first two we already addressed, which are the investigation of what is the effect of applying Uni-REPM for safety critical systems when it is instantiated in different safety critical domains? Second, what is the level of acceptance of Uni-REPM for safety critical systems by practitioners? We have conducted a dynamic validation following the technology transfer framework, where we use the safety model in industry to evaluate the requirement engineering process of 7 companies that act in different safety critical domains, and the practitioners have many years of experience. We interviewed 7 practitioners, being 3 from Brazil, 3 from Sweden, and 1 from Germany. The results of this dynamic validation show that none of the 7 companies satisfied all the actions of basic level 1, of Uni-REPM for safety critical system, being classified as insipid. But the results also show that the latency analysis show that their companies are close to completing Uni-REPM actions. The results also show that practitioners did not perform any additional actions that are not covered by our safety model. There is no significant effect of applying Uni-REPM for safety critical systems when it is instantiated in different safety critical domains. And the model has a good level of acceptance by practitioners, and also had in the static validation presenting this work. And finally, the model lag analysis show that the model has a good applicability, and the proposed safety actions are in fact used by companies that develop safety critical systems. The results of this dynamic validation will be published in another paper. The remaining open issues are: which are the context factors that influence the maturity level of an organization? What is the model impact considering before and after assessment of companies? Can practitioners reconsider the actions in the model with what they already need to do in order to comply with mandatory standards in their application domain? And are there any conflicts among the model and the standards and existing company practices? We intend to address such questions in future works. We appreciate your attention, and if you have any questions or if you work with software engineering, safety critical systems, or information security and want to collaborate, please contact me.